So when should we use substitution and when is it not necessary? So we'll look at three problems on this slide. So first off, if you're given 3x plus 1 is greater than 10, don't don't waste any time writing u equals 3x plus 1 just to have u is greater than 10, because then, well, you've solved for u and you just need to replace the u again with 3x plus 1. So just take 3x plus 1 greater than 10, subtract 1 on both sides, you get 3x is greater than 9, then divide by 3 on both sides and you get x is greater than 3. Now, if you're given absolute value of 3x plus 1 is greater than 10, then it really makes sense to say that u should be 3x plus 1 so that you get this much nicer looking problem. Absolute value of u is greater than 10. So you go from this kind of wacky looking absolute value inequality where there's a lot of stuff in the absolute value to just having the variable in the absolute value, the new variable, and that's because we made the new variable equal to all the stuff that used to be in the absolute value. We just made u equal to 3x plus 1 with no absolute value here. It's just the stuff that's inside the absolute value. Right? Then you can answer the question, what values of u satisfy absolute value of u is greater than 10? And then you'd go back and finish, by substituting in reverse. Every u would then become a 3x plus 1. Now, if you're given absolute value of x is greater than 10, I think some people are going to try to substitute, because this is an absolute value inequality, they're going to substitute u for x. Now that's valid, but then all you have is absolute value of u is greater than 10. But here's the thing, absolute value of u greater than 10, is that really any different than absolute value of x is greater than 10? It's not really any different, right? So it just doesn't seem to be the type of question where we should spend any time doing that substitution. It's not necessarily wrong, but this slide is really just trying to talk about, look, substitution does take a little extra time, but when is it the right time to do it? When is it not really necessary to do it? So for the interactive question, can you put in your own words, what circumstances should you look for to apply substitution in an inequality? Let's take a look at solving a more complicated inequality. 2 plus 3 times the absolute value of 4x plus 5, close absolute value, less than 6. Now there's no 2 plus 3 here. Don't turn that 2, I know it looks like there's a 2 plus 3 to start. Don't turn that into a 5. Order of operations still applies. It's 3 times the absolute value thingy, which happens first. So let's just undo that plus 2 term by subtracting 2 on both sides. So 3 times absolute value of 4x plus 5 is less than 4. Divide both sides by 3. Aha, now we have absolute value of stuff less than a number, namely the number 4/3. So this is the point at which I think it would be helpful to create a variable for the stuff that's inside the absolute value. So we'll create u as a variable to be 4x plus 5 so that the problem we have on the previous line turns into absolute value of u is less than 4/3. Now that it's just absolute value of just a single letter is less than a number, 4/3, we can now spot check, pick values of u. Does u equals 0 work? It sure does, right? U equals 1 still works because 4/3 is like 1.3 repeating. But just the fact that 0 works tells us that we should be creating a number line diagram for u that would look like this. And so u has to be both bigger than negative 4/3 and has to be smaller than positive 4/3. And notice that there's no absolute value in what's written here because we're finally providing an answer about what u should be. In fact, the number line diagram is an answer about what u should be. We are reporting on the values of u that work for the inequality absolute value of u is less than 4/3. Now, though, that these two inequalities have u solved for, right, because u is by itself, not absolute value of u by itself, but down here, u is by itself, we can replace each u with a 4x plus 5. So 4x plus 5 is greater than negative 4/3, and 4x plus 5 is less than 4/3. Subtract 5 on both sides of both inequalities, and then divide by 4 on both sides of both inequalities. We end up with x is greater than negative 19/12, and x is less than negative 11/12. So we can draw that on a number line diagram. Looks very lopsided, sorry, but well, both of the numbers are negative, so they're just kind of drawn, kind of tilted quite a bit over to the left side of this. And then we can write this in interval notation as well, as parenthesis negative 19/12, comma negative 11/12 parenthesis. Okay, let's take a little moment to talk about the word and versus or. So if you see x greater than 6 and x is less than 8, then this means that we keep a number if it is bigger than 6 and it is smaller than 8. If you see x is less than 6 and x is greater than 8, this means we would keep a number if it is smaller than 6 and it is bigger than 8. Now, stop and think about that for a second. There is no number which is smaller than 6 and bigger than 8. So putting and here means that we wouldn't really get any numbers at all by doing this. So in this situation, the word or applies. Now, or has a very technical meaning. So reading x is less than 6 or x is greater than 8 means we keep a number if it is smaller than 6, or if that doesn't happen, it is bigger than 8. So 5 is a number that's either smaller than 6 or bigger than 8, so we keep it. 9 is a number that's either smaller than 6 or bigger than 8. It just happens to satisfy the bigger than 8 part, so we keep it. 7 satisfies neither, is neither smaller than 6 nor bigger than 8. So 7 is not included when you describe x is less than 6 or x is greater than 8.